This is video 2 on electron configurations, and this is on writing the electron configurations, so 3 ways that we can do that. The first way is probably the longest way, and this is the orbital notation. So orbital is represented by a line, and then the orbital name is written under that line, so this is orbital 1s. An orbital that has an electron is written as an up arrow, and then when there are 2 electrons, remember that we learned from the last slide that 2 electrons in the same orbital cannot have the same spin, so that second electron would be written with a down arrow. I'm not sure why this line is not there, but we see for helium there are 2 electrons in the 1s orbital, so 1 is up and 1 is down. Further down for carbon, we see that the 1s orbital and the 2s orbitals are both full with 2 electrons, and then when we go to 2p, remember from yesterday, our filling order, that the orbitals that only have 1 electron in them have to have an up spin if they're alone. I'll do the example for sodium here. So this diagram, energy diagram, is just there to remind us the order that we fill in. So sodium has 11 electrons. So I'm going to start with the 1s orbital and fill in the up and down arrow. The 2s electron, or the 2s orbital, is also filled with 2 electrons. For sodium, the 2p orbitals will all be filled. So each 2p orbital is going to have an up spin electron and a down spin. And then our very last electron, the 11th electron, is going to go into the 3s orbital, and that will be an up spin. The second way to write this is called the electron configuration notation. And it makes it a little bit easier for us, less writing. So instead of drawing the lines with the energy level and sublevel under it, we just write the energy level and sublevel, and however many electrons are in that orbital, we write as a superscript right after the energy level and sublevel. So we see for lithium, with the orbital notation, we had the lines drawn as boxes here, but with the up spin and the down spin, we don't have to worry about that with electron configuration notation. You just put the energy level, the sublevel, and then the total number of electrons as the superscript. So the third way to write it is probably going to be your favorite because it's a shortcut method. It's called the noble gas notation or noble gas configuration. And what this does is just takes the noble gas that's closest to the element that you want, that's before it, and it takes that configuration and just shortens it by putting the noble gas in brackets. So you have to have the brackets there for it to be the correct notation. And I'm not sure what happened with this slide, but this should actually be a superscript as well as all those numbers underlined in red. So the configuration for neon is 1s2, 2s2, 2p6, which is here, and we can just represent that as neon in brackets and then continue on. If we wanted to find sodium, we would still have to write the 3s1 after the neon. So it's neon plus 3s1. So you can do this for any element that is greater than 10, which means any element that's past neon on the periodic table. So I'll do titanium as an example. So the noble gas that's closest to titanium, that's before it, is argon. So I would write Ar for argon in brackets. Then I would continue on with that configuration. So after argon, I would have to still write a 4s2 and a 3d2. So this would be the shorthand notation for titanium. So we'll probably use this third type, this noble gas configuration, in class for most of our examples, almost all of them, but you will have to know how to do at least one example of each for your exam on this unit.